Hello friends, welcome to my channel. Let's have a look at problem 712, minimum ASCII delete sum for two strings. In this video, we're going to share a treatment based on dynamic programming. First, I'll read through the problem statement to digest the requirements. And then we do the analysis, and finally we share the code. So in this video, we want to demonstrate that the proper choice and interpretation of the DP table element will bring us convenience for reasoning and coding. First, the problem statement. So given two strings S1 and S2, return the lowest ASCII sum deleted characters to make the two strings equal. So here are two examples. So in example 1, so the deletion is that we delete S from C, and also we delete T from each. So add the two together, so we get an ASCII sum 231. So similarly, you can interpret the output 403 for example 2. Before we do the analysis, let's also look at the constraints. So first, the length of the two strings are bounded below by 1. In other words, they are non-empty, and bounded above by 1000. And secondly, S1 and S2 consist of lowercase English letters. So with that said, actually we can look at the analysis. So in this problem, actually the hint give us a very suggestive hint, starting point. So first, we are going to let dpij be the answer for the input S1, so starting from index I onwards, and S2 starting from index J and onwards. So here you can understand the I as the row index and J as a column index, or you can understand ij as the argument for the function dp, or you can regard dp as a table. So here m and n are the lengths of S1 and S2 respectively. So with that set up, we are ready to do the initialization. So first thing we want to emphasize is that, so here the DP table we're going to use is m plus 1 by n plus 1, so that's minus 1. So for I equals m, so if I equals m, so S1 I onwards will be empty. Then we just need to delete all the things, all the characters from S2 J onwards, right? So then the corresponding DP table value should be the summation of the ASCII order numbers. So similarly for J equals n, we need to delete all the things from S1 onwards, I onwards, right? So this initialization is based on the DP interpretation, right? So once we make the choice of DP interpretation, so this initialization is very straightforward and especially very natural. So with that said, we are ready to look at the DP update rule or the recursive relation. So here, if S1I equals S2J, and then the dpij would be equal to dpi plus 1 j plus 1, because we do not need to do any operations for the two characters. So otherwise, we are going to pick the minimal ASCII sum for the possible deletion. For example, if we delete SG, right? So here S2J, right? So or we delete S1I, right? Or we delete both S1I plus S2J. So the smaller of these three will give us dpij, right? So this is the general DP update rule. So with that done, so actually we can do the coding easily. So the fourth item actually is a walkthrough. So here for briefness, so we just to give the DP table final state for the two examples. So for the first example, so the final state is this. So what we are going to return is dp00, right? That's 231. So similarly, for the example 2, so this is the return 403. So when we do the setup, actually we can set the last row and last column, and then we gradually set up the middle elements until we set the top left corner. So with that said, we are ready to do the coding. So we just need to translate the above analysis into code format. So first, I'm going to track the length for the two strings S1 and S2. So this is just for convenience. And then we're going to initialize the DP table. So as we mentioned, so we're going to use a m+1 by m+1 table or matrix for range m+1. So with that done, let me first do the initial setup. So here, let me first set the first, let's see, the last row. So this corresponds to I equals m. So for j in range, so we're going to iterate from the reverse order, right? Ending at 0. So we write -1 here. So this way, so we get m and j. It's going to be and dp m j +1, and then plus the ordinal number of S2j, right? And then we're going to do this for the last column, right? That is for m -1, -1, -1, and then dp I, this is the last column, the nth column. So the index is n, but if we count it from 1, it will be n +1. So we're going to have I +1 n, then plus the ordinal number for S1I. So this is the initial setup, and then let's do the DP update. So for this, we're going to make a double for loop. So m-1, -1, -1. So for j in range m-1, -1, -1. First, let's examine this case. S1I equals S2j. If this is the case, so we're going to do this. Ij equals dp I +1 j +1. Otherwise, so let's do a very rough analysis. Let's do this. dpij will be the minimal of dp I +1 j. So this is the result for I +1 j, and then we are meaning that we are needed to add the S1 I, right? So similarly, let's do dp I and j +1, and then add the deletion for effect for S2j. So actually this will be fun, but let's also do just this. Let's do dp I +1 and j +1. Let's imagine that we delete both. So S1I plus S2j. So this way we finished the setup for the DP table. So next, so we just need to do return DP not 00, right? So this is a solution format for this problem. For now, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So that's about it for this specific problem. So actually, it's for using the dynamic programming in a tabulation format. This is very routine. So here there are 2 points we want to emphasize. In general, so when we choose or make proper interpretation for the DP table, it brings us convenience for doing the initialization and for understanding the reasoning and the logic. And secondly, specifically to this problem, so here we are iterating in a backwards fashion. So with that said, I guess that's about it for this simple problem. So with that said, thank you.